Okay, I'm back on a roll now. I've remembered how to do this. It's been a while since I've done my online. I got rusty over the summer. Okay, so let's take a look at question 6 here. All right, it says if an object falls for 2 seconds and it started from rest, what will be the object's speed when it reaches 2 seconds? Okay, this is in meters per second. Or yeah, and then we'll do question 5 at the very end because I'm going to rearrange. I got to remember question 5 to 11. Okay. All right. So anyway, if an object falls for 2 seconds, so let's take a look at what we're doing here. This is what we're doing. We've got an object that falls. We're assuming that the acceleration of the object is g is 9.8 meters per second squared, and t is equal to 2 seconds. All right. So we're going to be using this equation here, where we want to find out how far it went. So that would be y final. It would be a y initial plus v naught in the y direction, or the initial velocity times time, plus 1/2 times 9.8 times t squared. Okay. All right, so we're trying to find yf. This is 0. This is 0 times 2 seconds, which will be 0, plus 1/2 times 9.8 times 2 seconds is 4. Oh, I think we did that on the thing, because 2 squared is equal to 4. I think you can do that. You plug in that number. I'm sorry I'm telling you how to suck eggs, but I just don't want you to be mad at me. No, anyway, I want you to be comfortable with the material, right? And get it right and move on, and you'll be fine. Okay, so if a car starts from rest and reaches 28 meters per second in 9 seconds, what is the car's acceleration? Ooh, this is a fun problem. So what are we doing again? I'm going to say a car starts from rest. So what does rest tell us? If it starts from rest, then we know that its initial velocity is 0. We don't know its acceleration. We don't know that. We know the time was 9 seconds, and we know that its final velocity was 28 seconds. And what is our definition of acceleration? Acceleration is equal to v final minus v initial divided by the time, or the change in speed or the change in time. So we've got this. We got to subtract those. 28 minus 0 divided by 9. Whatever happens, happens. There. So see, this isn't bad. And I'm sorry I told you how to suck eggs on that one too. I shouldn't do that. I should make you struggle, make you suffer. Okay, all right, now I'm going to stop here and we're going to look the next 3 questions. And then we'll look at the final. So let's go to question 5. So I'm going to put question 5 right here after question 8. Okay, that's what I'll do. All right, so question 5 says, use the formula for reaction time. What is the reaction time for someone who let the ruler fall 20 centimeters? Well, let's take a look at that. All right, let's take a look at that. So if it fell for 20 centimeters, now this gets a little bit tricky. So hang in there. So if something falls, so if I know that y final is equal to 1/2 gt squared if its initial velocity was 0. All right, that's if its initial velocity was 0, and we count the initial height as 0, and the initial height is 0. For our purposes, those will always be the case. How do I solve for t? It's got a squared, so I'm going to have to take a square root, but it's not that bad. So we go 2 times y final divided by 9.8, and then we take the square root of the whole thing when we're done. That's what t is equal to. Take the square roots of both sides, because what do? I multiply both sides. So let's just do this 1/2 gt squared. Let's just do the algebra is equal to y final. And I'm trying to solve for t. So I multiply both sides by 2. So I get gt squared is equal to 2y final. Divide by g. And I get t squared is equal to 2yf divided by g. Now I take the square roots of both sides. So I'm going to give you, let's say y final is equal to 0.33 meters. Okay? I know that g is equal to 9.8 meters per second squared. Here's how I would do this on my calculator. I would take 2 times 0.33 divided by 9.8. Then I'd write that number down. Okay? So I'm going to take 2. Actually, on my calculator, I could do this all in one fell swoop if I felt like it. So I get 2 times 0.33 divided by 9.8. And I get kind of a small number here. 0.067. Your numbers are going to be small. 0.0673 seconds. That's what that came out to be. Okay? But I'm not, that's seconds squared. I'm not done yet. I've got to take the square root of 0.0673. On my calculator, that looks a little bit different. I go second square root, I hit the square root button. On some of your simpler calculators, you just hit the square root button and it'll give it to you. And I'm going to go ahead and tell it to put in the answer. Boom, 0.2595. And go ahead and carry it out 4 significant figures like that. So the reaction time of that person was 0.2595 seconds. Now let's learn how to use the software, because I'm going to make you do because you're doing an experiment, so you got to run some statistics. Okay?